Yeah. Assalamu alaikum, my dear students. So I hope you'll be fine and doing great in your life. So today we are going to discuss about the Coulomb's law. So I'm going to write Coulomb's law. So my dear students, what is Coulomb's law? Okay, so my dear students, I'm going to take 2-point charges. Say beta, this is your Q1 and this is your Q2. Okay, I take two stationary point charges. One is, my dear student, that's your Q1, and second is Q2. And these 2-point charges are separated by a distance of r. And these 2-point charges are separated by a distance of r. Is it clear? Okay, good. Now, as per the Coulomb's law, whenever we have two stationary point charges and these are separated by a distance of r, and they will allow to have the force of attraction as well as force of repulsion. If they are like, they will tend to repel with the force of repulsion, and if they are unlike, and they will allow to attract with the force of attraction. So as per the Coulomb's law, whenever we take two stationary point charges and these are separated by the distance of r, then the force of attraction or repulsion between these two stationary point charges is given by, if we calculate that force, that F is going to be directly proportional to the product of charges and inversely proportional to the square of distance between them. So it is clear, my dear student, whenever you want to calculate the force of attraction or force of repulsion between the two stationary point charges and these are separated by a distance of r, and that force of attraction or repulsion is directly proportional to the product of charges and inversely proportional to the square of distance between them. Okay, great. So now we are going to remove the proportionality. We are going to remove proportionality and we are going to use the constant. And my dear students, we are going to have F is equal to, that is going to be K times Q1 Q2 divided by R square, where K is the constant and that constant is known as Coulomb's constant, or we say it's the electrostatic force constant, and that K is equal to, my dear student, is equal to 1 by 4 pi epsilon. Okay beta, and that value is equal to 9 into 10 the power 9 Newton meter square per Coulomb square. Okay, great. Here 1 is the constant, 4 is the constant, and pi is the constant. We have, my dear student, we have epsilon. So what is epsilon? Epsilon is, my dear student, that's your permeativity of free space, or we say, my dear, vacuum, whose values, my dear student, be very clear: 8.85 into 10 the power minus 12 Coulomb square per Newton meter square. So this is just a statement of the Coulomb's law. Whenever you are going to have the two stationary point charges and these are separated by a distance of r, and you want to calculate that force of attraction or force of repulsion, that force of attraction or repulsion is going to be directly proportional to the product of charges and inversely proportional to the square of distance between them. Is it clear, my dear student? That's very much clear. So this is just a statement of the Coulomb's law. But see, my dear, we just explain about the point, take about the stationary and the point charges. What is actually a point charge? So point charge is that sort of charge which do not have any sort of which do not have any volume, which do not occupy any sort of area. And in fact, my dear, when you say the point charge, these do not have any sort of area, they do not have any sort of volume. It means that the distance of separation between the two charges particles is not going to be affected by the point charges. See beta, यहाँ पर अगर आपके पास this is point charge Q1, this point charge your Q2, means they are truly beta small, and इनके बीच में जो distance of separation that's r. Now, if they occupy some area, they occupy some volume, then the distance between them is going to be suffered. So that's why whenever you are asked about the point charge, they are truly the small, they don't have any sort of area, neither they have any sort of volume. Now see, my dear, we are going to go to the next slide. Now we are going to have, see, my dear students, wait a second. Okay. Now in next what we are going to discuss about now, we are going to discuss about some application of your some concepts about your Coulomb's law. How can we apply the Coulomb's law to find the force of attraction or repulsion between 2 point charges? See, my dear, we have one concept number one, my dear students. Concept number one, okay. लेट आपके पास दो अल्फा पार्टिकल्स है. लेट माय डियर स्टूडेंट आपके पास दिस अल्फा पार्टिकल नंबर वन एंड दिस इज योर अल्फा पार्टिकल सेकेंड. Okay, and these two alpha particles are separated by the distance of r, and that r is, my dear, that's your 5 angstrom. You have two alpha particles, and these two alpha particles are separated by a distance of separation between them is, that's your 5 angstrom. And you want to calculate that force of attraction or force of repulsion between them. As we know that, my dear student, as per the Coulomb's law, that F is equal to K times of Q1 Q2 divided by R square. Is it clear, my dear student? That's very much clear. Now see here, we have one charged particle Q1, that's your alpha particle, and again the second charged particle Q2, that's your alpha particle. Now see what is the charge. Here we know that K, that's 1 by 4 pi epsilon, and whose value is 9 into 10 the power 9 Newton meter square per coulomb square. And we have R, that's 5 angstrom. Here the matter is, my dear, matter of concern is that we have Q1 and Q2. And what the values that we are going to put on. See here, we know that alpha particle whose charge is always, my dear, that is twice of E, twice of electronic charge. And similarly यहाँ पर भी आपके पास अल्फा पार्टिकल है, and who charge is again going to twice of electronic charge, twice of E, and that is going to be, my dear student, twice into 1.6 into 10 the power minus 19, that's going to be, my dear student, 3.2 into 10 the power minus 19 coulomb. And similarly, my dear student, this side we are going to have twice of E, that's 1.6 into 10 the power minus 19, that's going to be 3.2 into 10 the power minus 19 coulomb. So be very clear. Now we are going to have the charges of the alpha particles, two alpha particles. One alpha particle have the charge 3.2 in the 10 the power minus 19 coulomb, and similarly another I am going to have 3.2 in the 10 the power minus 19. Why? Both are alpha particle, and alpha particle carry the charge of twice of E. And these are separated by distance of 5 angstrom, means that is 5 into angstrom means 1 angstrom, that's 10 the power minus 10 meter. So these are separated by distance of 5 into 10 the power minus 10 meter. Now we want to calculate the Coulomb force between them. We want to calculate the Coulomb force between the two alpha particles, two alpha charged particles. So that is given by Maria. So that is F is going to be K, and we know that K is going to be 1 by 4 pi epsilon, and that value is going to be, my dear student, 9 into 10 the power 9. Into Q1, and Q1 we are going to have 3.2 into 10 the power minus 19. Again Q2 we are going to have 3.2 into 10 the power 9 minus 19 divided by your R, and that R is, my dear student, 5 into 10 the power minus 10 ka square. Is it clear? Great. And that's going to be, my dear students, it is going to be, see here, 9 into, that's going to be 9 into, okay, 10 the power minus 19, that is going to be minus 38 में 9 घटाएंगे, that's going to be minus 29. So it is going to be 10 the power minus 29. And then after that we are going to have 3.2 into 3.2. That's going to almost 10.28. Divided by, my dear student, 5. It means there is a square of 5, there is a square of 10, 10 the power minus 10. So it is going to be 5 5s are 25, and when you square 10 the power minus 10 ka square, that's going to be, my dear, 10 the power minus 20. So it is going to be, my dear students, 9 into 10 the power minus 29 into, my dear, 10 the power into 10 the in the 10 the point 28 raised to power 20 minus 20, that's ऊपर क्या जाएगा, that's going to 10 the power plus 20, and divide by, my dear student, 5 5s are, that's your 25. So we are going to have calculation on the next slide. We are going to have the calculation of, if you go to the back slide, 9 into 10 द पावर 20 में से 9 घटाएंगे, माइनस 29 से 20 घटाएंगे, दैट्स गोइंग टू बी माइनस 9. सो 9 इंटू 10 द पावर माइनस 9, वी आर गोइंग टू हैव 9 इंटू 10 the power minus 9 into 10 the point 28. Okay beta, divided by, go to the back, ye cover, this cover, and 9, and divided by 25. Divided by 25. It is going to be, my dear students, 9 into 10, it is going to almost beta, that's going to be 9 into 10 the power 28. It is round off going to be, if we calculate this on the sideways, we are going to have 9 into 10 the power 28 is going to almost your 92 point, almost, my dear, 9 tens are 90, and 0.28 beta, it is going to be 9 eights are, that's going to be your 9 is a 56, 6 5 carry, 9 twos are 18, 18 or the 5, that's going to be beta, 9 is a 56, 5 carry, 9 to 18, and 5 okay beta, that is going 23, 3 2 carry, 900, that is true. Okay beta, 0.2.36, and it's going to almost 92.36. Okay, divided by, my dear student, into 10 the power minus 9, okay, divided by, my dear, so 25, and when we calculate this is going to almost 3 point, okay, my dear, 25 3 75, 25 3 point something, my dear, 8 into 10 the power minus 9 Newton. Okay, my dear, is it very clear? If we calculate this, this is going to be 92.36 divided by your 25. That's going to be, my dear student, 92.36 divided by 25. That's going to be 3.69. You can write, my dear, that's 3.7. You can write, my dear, that is 3.7. This is your answer. So whenever you want to calculate the Coulomb force between two uncharged particles, two point charges, you can easily calculate. Have the next more question, my dear student. We are going to have. We have two charged particles. One is, my dear student, that's your plus of Q. Okay, great. And second is, my dear, that's your minus of Q. Okay, it's clear. And these charges are separated by a distance of r. Okay, one charged particle, let beta, that's your plus q, I will name it beta, that's your a, and minus q, I will name it beta, that's your b. So means you have two charges, one is plus q and second is minus q, and these are separated by a distance of r, and plus q we name it as a, and minus q we name it as a b. And examiner is asking, if plus q, your plus q shares 25% of charge, 25% of charge to minus q, then what will be your new force between these two charged particles? Examiner is asking you, my dear student, if we have two charged particles, one is minus q, second is plus q. Plus q sharing 25% of charge to the minus q. And when these two charges, these two charge particles share the charge, examiner is telling, after sharing of the charge, what will be the new force between them? Be very clear, my dear student, be clear. How can we solve? Here we have two cases. First, when the sharing of charges was not taking place, that time the force between them was, my dear, F. Now after sharing of the charge of 20% from plus q to the minus q, what will be the now new F? Okay, my dear, so be clear. As per the Coulomb's law, we know that F is equal, that's going to be Q1 Q2 divided by R square. Is it clear? Very great. When there was no sharing of the charge, when there was no any sort of sharing of charge, my dear student can write, so F is going to be K times of, and Q1 we have, that's plus Q, and we have Q2, that's going to be minus Q divided by R square, and that is going to be minus K Q square divided by R square. That is going to be F when there was no sharing of charge. When there was no any sort of sharing of charge between the 2 point charges, one is plus q, second is your minus q. Now after the sharing of charge 25% from plus q to the minus q, what is going to happen? Now after sharing of the charge, now plus q is sharing to minus q, separated by the distance of r, almost 25% of charge is to minus q. First, we want to calculate how much 25% of charge mean. How much 25% of charge mean? That plus q is giving to the minus q. First, we want to calculate. If this body is giving 25% to the minus q, that means it is losing 25%. And minus q is 25% gaining. One is losing 25%, another is gaining 25%. So net remains conserved. See, my dear student, so first 25% means 25% of that's q. It is going to be 25% divided by 100 into q. That's 25 ones are 25 fours are. That's q by 4. So it is giving q by 4 to the minus q. So 25% means that it is giving q by 4 to minus q. So now what is the charge that is remaining with the plus q? Remaining charge now. After sharing remaining charge. So plus q is going to have q, it is sharing how much charge? 25%. 25% means q by 4. Now इसके पास कितना बचा हमारे पास? That's going to be q minus q by 4. That is 4q minus q, that is 3q by 4. So body A going to have 3q by 4 after sharing 25% of charge. Now we are going to have the charge body second, that's minus q. After getting to 25%, how much charge it is going to now have? It is going to have, so we are going to have, after receiving the charge of 25%, that's q by 4, it is going to have minus q divided minus q, and after getting the charge, that is plus q by 4. So minus q is getting the charge of, minus q is getting the charge of 25%, that's q by 4. Okay, we are going to have minus 4q plus q, that is minus 4 को q you are going to deduct बेटा, आप q इसको minus करेंगे, minus q plus q, minus 4q plus q, that is going to be minus 3q by 4. So new charges after sharing of charge, plus q body is going to have the now charge 3q by 4, and second body is going to now have the charge of minus 3q by 4, and they are separated by the distance of r. And now you are asked to find the f new. Okay, f new is going to be, my dear student, f new is going to be f is equal to k times of q1 q2 divided by r square. Okay, that's going to be f is equal k as it is q1, that's going to be 3q by 4, and q2 that's again going to be minus 3q by 4 divided by r square. And it's going to be, my dear student, I'm going to write here, it's going to be f is equal to q plus minus minus, that is going to be 339 q square divided by 4 4s are 16, and ऊपर जाएगा r square, that is going to be 1 by r square. And f new is going to be, I will write that it is f new, that I'm going to calculate f new after sharing of charge. F new is going to be, see here, as we know, my dear student, minus, can I write it is 9 by 16, get it front, okay, 9 by 16 को आगे लाए, and it's going to be minus qk square divided by r square. As we know, my beta, then we are going to have c here, and f minus qk minus kq square r square was your force when there was no sharing of charge. So can I write, instead of minus kq square instead divided by r square, can I write it is, my dear, your f. Okay, so we are going to have, so that's going to have, bring it minus f 9 by 16, and this value is going to be your f. So new force will be 9 by 16 of f. Is it clear? That's too easy, my dear student, very easy. So you can easily solve this question. How can you find, you have any two charged particle, you want to calculate the force of attraction or repulsion between them, you can easily solve this. Now moving to the next. For example, we have some charged body, that's q. Okay, my dear student, q. And this charged particle is divided into two charges. One is, my dear, that is q square minus 2q, and let another charged body is that's with you is 3q. Okay, that's your 3q. This is your charged body, and you have some charged body that is q. It is split, it is broken into two charges. One charge is q square minus 2q, and second is 3q, and these are separated by the distance of r. Examiner is telling you What is the relation between Q and Q? For to have the maximum force, then meteor, for the maximum force of repulsion, what is going to be the relation between Q and Q? See, Maria, how can we solve this question? First, we are going to calculate F. As per the Coulomb's law, F is equal, that's going to be Q times Q1 Q2 divided by R square. And F is going to be, that's going to be K means 1 by 4 pi epsilon. Okay, great. Q1, that is going to be, now this is going to be Q1 and this is going to be your Q2. Is going to be Q square minus 2Q multiplied by, that's going to be 3Q and divided by R square. And F is going to be, my dear students, 1 by 4 pi epsilon, and multiply this, it is going to be Q square 3Q and plus minus 2Q, 3 2s are 6Q square divided by R square. So this is your force between these two charged particle. One is Q square minus 2Q, second is 3Q. Now the examiner is telling, my dear, so be very clear, examiner is telling for the maximum force of repulsion, what's the relation between Q and Q? So for the relation between Q and Q, we know that the differentiation of your F with respect to Q should be equal to 0. So I have to just, my dear, differentiate this equation. That is, F is equal to 1 by 4 pi, where F we are going to have 1 by 4 pi epsilon. Okay, 1 by 4 pi epsilon Q square 3Q, Q square 3Q minus, okay, minus 6Q square, minus 6Q square divided by R square. So after differentiating, we are going to have, that's dq d by dq of F, that is 1 by 4 pi epsilon Q square 3Q minus 6Q square divided by R square is going to be 0. And 1 by 4 epsilon bahar, constants all bahar, that's going to be 1 by 4 pi epsilon R square bahar, and then going to be differentiation with respect to Q, and inside we are going to have Q square 3Q minus 6Q square is going to be 0. And when it goes with the multiply this whole going to be cancelled, it's going to be 0. And by having the multiplication with the 0, 1 by 4 pi epsilon R square, after cross multiply, that's going to be 0. Now we are left with, my dear, d by dq of Q square minus 3Q minus 6Q square is going to be 0. After differentiating both, we can write this Q square, it is Q square, not a minus, not minus here. Q square 3Q. Okay, now differentiating with respect to Q, it is Q square as it is 3 bahar, okay, 3 outside, Q square it is, and differentiation of Q is 1. Minus 6 as it is, 2 down, power down, power minus 1, 2 down, and Q 2 minus 1, that's 1, is going to be equal to 0. It is going to be 3Q square minus 6 2s are 12Q is going to be 0. And we are going to have 3Q square is equal to minus plus, that's going to 12Q. And we are going to have Q square is equal to 12 by 3Q. That is 3 1s are 3 4s are. We are going to have Q square is equal to, I'm going to write here. Okay, we are going to have Q square is equal to, that is going to be 4Q. Q square is going to be 4Q, and we are going to have Q is equal to under root of your 4Q, and we are going to have Q is equal to root of 4, that is 2 under root of Q. This is a relation between Q and Q. So this was just a simple question examiner was asking you, or some can also write as here. After solving, we get Q square is equal to, we are going to have Q square is equal to 4Q. In fact, you can write, my dear, Q is equal to divide, that is Q square by 4. Even you can write this ways. That's not a big deal. So the relation between Q and Q is that Q square is 4 times Q, or Q is equal to under root of 4Q, or Q is equal to Q square by 4. This was just again one charge is divided into two parts, and then now you are asked when what is the condition for the maximum force of repulsion and what is the relation between Q and the Q. Is it clear? That's very much clear, my dear students. Now, moving to the next. Moving to the next slide. Now we are going to have, this was just a small exercise you are going to have on the Coulomb's law, and in fact there are a lot of cases, your suspension cases, two pith balls are suspended, you have some block, okay my dear student, you are having some block that is sitting on some part where what is the distance, so that block can be equilibrium with the charge that is at the bottom. Is it clear, my dear? So now, moving to the next, we are going to have the unit of charge. Now, first we are going to discuss about unit of charge. Now, we are going to discuss about unit of charge. So, before discussing about the unit of charge, see my dear what I am going to have. So I am going to take 2 point charges. One is Q1 and second is Q2. And these are separated by the distance of R. Okay, so now going to discuss about the unit of charge. I have taken the Q1 and second is Q2. And these are separated by the distance of R. Let my dear, we are going to have Q1 is equal to Q2 is equal to, that's going to be 1 coulomb. And the distance of separation between them is going to be, my dear student, that's going to be 1 meter. Now, as per Coulomb's law, then we are going to have F is equal, that's going to be K times of Q1, Q2 divided by R square. And my dear student, we are going to have F is equal, we are going to take QK, that's going to be 1 by 4 pi epsilon. Okay, and Q1 that's going to be 1, and Q2 that is again going to be 1 coulomb divided by R, and distance of separation is, my dear, that's 1 meter, that's 1 ka square. And we are going to have F is equal, that's going to be 1 by 4 pi epsilon, because this is going to be cancelled out. That's 1 by 1. That's also always 1. So 1 into 1 by 4 pi epsilon, that's 1 by 4 pi epsilon. And we know that 1 by 4 pi epsilon is always 9 into 10 the power 9. So we are going to have the force of 9 into 10 the power 9 Newton. So that means whenever you are going to discuss the unit of charge, it can, so 1 coulomb, whenever you are going to discuss about the 1 coulomb, it means it can exert the force of 9 into 10 the power 9 Newton. That's why we say when we take two similar and equal charge separated by a distance of 1 meter will exert force of 9 into 10 the power 9 Newton. That's how we define unit of charge. So to define the unit of charge, I did just nothing. I take two charges, whose charge I put 1 coulomb, same. And they are separated by a distance of 1 meter. After solving this, we got the force of, they'll exert the force of 9 into 10 the power 9 Newton. So 1 coulomb is not a small charge. It's a very big charge. It can develop the force of, it can exert the force of 9 into 10 the power 9 Newton. And that's why whenever you define a unit of charge, two similar and equal charges are separated by a distance of 1 meter, and they will exert the force of 9 into 10 the power 9 Newton. That way I say it's unit of charge. Is it clear? Okay, now next, going to move. Now, going to discuss about Coulomb's law in vector form. Coulomb's law in vector form. See my dear, for discussing about the Coulomb's law in the vector form, I take two charges. One is Q1 and second is again Q2. And these are two stationary point charges. Okay, my dear student, and these are separated by the distance of R. These are separated by the distance of R. Okay, my dear, and these two charges are similar, and we know that when we have the similar charge, they will tend to repel by the force of repulsion. So this charge is going to repel, and again this charge is going to repel by the force of repulsion. And this charge is going to repel by the force I will take, that is 2 due to force on 2 due to 1. And similarly this charge is also going to repel force on 1 due to 2. जब तक आपके पास 2 पे फोर्स 1 नहीं डालेगा ये रिपल नहीं करेगा. सिमिलरली 2 1 पे 2 नहीं डालेगा ये भी रिपल नहीं करेगा. सो दीज आर लाइक चार्जेस एंड लाइक चार्ज टेंड टू रिपल बाय द फोर्स ऑफ रिपल्शन. नाउ सी माय डियर, so let q1 its position vector facing towards 2 is r12 cap. Means charge 1 is facing towards this 2 and let position unit vector of your q2 is that's your beta r21 cap. Means 2 is facing towards the 1. Is it clear? So first of all, what we did, my dear student, we take two similar charges, they will tend to repel by the force of repulsion. This charge will also repel, this charge also will repel, but this will not repel until and unless this will not imply force on it. And similarly, this will not repel until and unless this will not imply force on it. So same I am going to here explain that. So q2 will not repel until and unless q will not imply force on this. That's why I write force on 2 due to 1 it will repel. And similarly force on 1 due to 2 it will repel. And to have this force of repulsion, I am just mentioning their position vectors, unit vectors. One is r12 cap, that is denoted your position of charge particle towards the 2, and similarly to 1, that is denoted your position of 2 towards the 1. Now see Maria, as per the coulombs now we are going to have F is equal, that's going to be K times Q1 Q2 divided by R square. As per the coulombs, but here we have two forces. One is that's one F12 and second is F2, and both forces are repulsive. But as per the coulombs law, what in vector form, what I am going to prove, and these two repulsive forces are going to be remember this point, equal and opposite. So first of all I am going to calculate F12. So that is going to be force on 1 due to 2, this one, it is going to be K times Q1 Q2 divided by R square. And remember my dear, force on 1 due to 2 will be when the charge 2 is facing towards the Q1. So position vector of Q2 facing towards the 1 is R21 cap, that is R21 cap. Similarly, my dear student, F21 for us is going to be K times Q1 Q2 divided by R square, and 2 on 1 is when the Q1 is facing towards Q2 and the position vector Q1 towards the Q2 is R12 cap, that is R12 cap. But we know that these position unit vectors are opposite. These are opposite. See Maria. So these both are opposite. So I can write R12 cap is equal to minus of R21 cap. So instead of R12 cap, I am going to write, my dear student, minus R21 cap. So we are going to have, next slide, we are going to have F21 is equal to K times Q1 Q2 divided by R square, and it was R12 cap, but R12 cap is equal to minus of R21 cap because these position unit vectors are opposite to each other. So instead of R12 cap, I am going to write minus R21 cap. That is going to be F21 is going to be K times of Q1 Q2 divided by R square. Instead of R12 vector, I am going to R12 cap. I am going to write, my dear, minus R21 unit vector, unit R21 cap. That is going to be minus R21 cap minus. Again, that's going to be K times Q1 Q2 divided by R square R21 cap. As we know, my dear students, see the first equation. K times Q1 Q2 R square R21 cap. K times Q1 Q2 R21 cap. That was your F12. That was your F12. That was your F12. So instead of this, I can write F12. So F21 is going to be minus of, and Q1 Q2 R square R21 cap from the first equation, that was your F12. So that's F12. So both these forces, see Maria, both these forces are equal and minus means opposite. So these are equal and opposite. That's why what we get from the Coulomb's line vector form. These both repulsive forces are equal and opposite. That's why Coulomb's law is analogous to the Newton's law. So it is analogous to Newton's law. Is it clear? Very much clear, my dear student. Very much clear. Okay. Now moving to the next. Some problem is. So today we are going to discuss about this, and tomorrow we are going to discuss about all the cases of the Coulomb's law. So we are going to discuss about the pith ball is suspended at the height of y, then suspend the height of y by 2. What will happen to the distance of separation? A block, there is an inclined block and some charged particle as the ground at the bottom. At what distance you place another charged particle so that will be in equilibrium? That will not slide. That is the case second. Then we'll discuss some suspension cases of the string as well. We'll take some equilateral triangles, put some charge at the centroids, hexagonal type, and that is going to be discussed in the next class. Until then, my dear students, take care. Khuda Hafiz. Bye bye.